Hello, this is Mr. Collier, and today we're looking at integrals with initial conditions. So I'll explain what that means now in a second. We saw before that when we integrate something, like this function, we get this function plus a c. So this is a cubic function, so cubics look like this blue line here, it's blue curve. But the plus c is basically a vertical translation, and you have an infinite number of answers. All of them look exactly the same shape, but they're in different locations like that. Okay, so this is an infinite number of answers, but if you have a piece of information, like for example, 0, 0 is a point on the curve, then you know it's this one right here, right? It's this curve right here. So basically, if you know initial condition, you can figure out which curve it is, and you can figure out the c value. So it's very important, especially for some real life situation problems. Okay, so we call the answer when you know the answer with the plus c is called the general solution. If you know which curve it is or what the c value is, it's called a particular solution. Okay. Alright, so let's take a look at this one here. Find the general solution of f prime of x equals 1 over x squared, and then find the particular solution that satisfies this. So this is basically the point 1, 0 is on the curve. So if I find let's rewrite this as x power negative 2. So the integral, or f of x, is going to be I'll increase the exponent by 1 and divide by negative 1, or just multiply by negative 1, same thing. Okay, so we have that function, which is like negative 1 over x, plus c. Yeah. Don't forget the plus c. So the plus c matters in this case, and that because now we're going to plug in x equals 1, y equals 0. So we plug in 0 for the y value, and for the x value, 1. So that means that c has to be equal to 1. So this means the particular solution, or the answer to that integral, has to be f of x equals negative 1 over x plus 1. Okay, so that's the equation of this curve right here, which makes sense. It's like a hyperbolic function, or a hyperbola with the vertical translation of 1. So it's got an asymptote here at y equals 1. Okay, let's take a look at this one. Now to find this integral is a linear factor, so I can increase the exponent by 1 and divide by 4 and divide by 2. So we have this 1 over 8 times 2x plus 1 to the power 4 plus c. Alright, so then we substitute this in to find out what the c value is. And we get the particular solution. So 9/8 equals 1/8 times 2 times 0 plus 1 to the power 4 plus c. So 9/8 equals 1/8 plus c. Subtract 1/8 from both sides, we get 1 equals c. Okay, so the particular solution is 1/8 times 2x plus 1 to the power 4 plus 1. Okay, the next one, we're going to get the integral of sine, which is, remember, that's negative cosine. So it's going to be negative 3 cosine 4x, and because we got a 4x here, we have to divide by 4. And don't forget the plus c. Okay, so that's the general solution. To get the particular solution, we substitute in 1 pi over 4. So 1 equals negative 3 over 4 cosine 4 times pi over 4 plus c. And then we have 1 equals negative 3/4. And that's cosine pi. Cosine pi is over here, so it is negative 1. So we have 1 equals negative 3/4 times negative 1 plus c. 1 equals 3/4 plus c. So we subtract 3/4 from both sides. We have 1/4 equals c. So the particular function is negative 3/4 cosine 4x plus 1/4. Okay, in the next example, the gradient of the normal to a curve at any point is equal to the x-coordinate at that point. So this is one particular curve with a special property. If the curve passes through this point, find the equation in the form. Okay. So that's basically, we integrate and we plug this point in. Okay, so we don't know anything about the function, so let's just call it f of x, right? And then the gradient, or the slope. The slope at the tangent, remember, equals f prime of x, right? So slope at a normal, because it's perpendicular to the tangent, is going to be negative 1 over, remember the slopes are negative reciprocals. So this part here, the gradient of the normal equals the x-coordinate. We can make an equation for that. Here's the gradient of the normal equals x. So we got that equation. So then we can get the reciprocal of both sides. We have f of x over negative 1 equals 1 over x. So f prime of x equals negative 1 over x. So now we can figure out what f of x is by finding the integral. And remember, the integral here is going to be negative ln x plus c. And then we're going to get it in this form, where g of x is a rational function. Okay, I think it's just x, but anyway, we're going to substitute in the point e squared and 3. So 3 is the y value, then we have negative ln e squared. Is it e squared? Yes, e squared. Plus c, so this is 3 equals, now ln of e squared is 2, so c equals 5. So we have f of x equals negative ln x plus 5, and if we want to write it like this, then I think we can use our log rule and write that as ln x to the power of negative 1, which is just ln 1 over x plus 5. Okay, but that's not quite the format that we want. We want just a function of x inside ln without a constant at the end. So here's how we can do that. We need to write it all as ln. So that is the same as ln e to the 5, right? And once I write it like that, I can combine that to give me ln e to the 5 over x is the final answer in the format that they want in the question.